Hi class, we need to take a look at example 6, and in this portion of the module we're going to be graphing two-dimensional inequalities. So here's the basic idea. You first need to take a look at what type of inequality you have. In this case, it's a greater. Greater represents in a two-dimensional plane that you're not going to be including the actual boundary. So what we're going to do here is we're actually going to graph the equation. In this case, y is equal to 3x plus 1, but with a dotted line. And the dotted line because we're not including the actual boundary. So for this line, we're going to need a y-intercept of 0, 1, a slope of 3 over 1. And let me just put those 2 points, 0, 1, it's going to be here. And let me use a different color. So 0, 1, it's going to be here. From there, we're going to count 3 units up. So technically 1, 2, 3, and 1 to the right. Now, the next step is crucial because we're basically talking about a line that's going to be dotted. So let me try to use the tools here. And in this case, I'm going to put a line, but our line is going to be dotted. So I'm going to have to move and also take a look at the type of line. So in this case, let me put the dashes. Let me make it a little bit thicker. Okay, that's sufficient. Now, here's the basic idea. We're going to be graphing all the coordinate points that satisfy this inequality, in this case, y greater than 3x plus 1. And this is going to translate to either shading one side of the line or the other side, since we're referring to all the coordinate points. So let me make that line a little bit longer so we can actually see both sides of the plane. And in this case, we're going to be looking either at these points or those points. Now, a lot of the problems are going to ask you to basically do algebra with test points. So what I'm going to do here is I'm going to select the coordinate point. In this case, for a test point, it's going to be any coordinate point that we're sure is in one side of the plane. So let me write it as test points. Oh no, this moved. Okay, so test points. And let me select the test point that for sure we know that it's in one side of the plane or the other. Let me select 1, 2, 3, and then 2. So technically this will be 3, negative 2. And I'm just picking a coordinate point that I know for sure is below the line. This is technically below, that's above it. So in this case, as an x and a y, we're going to be picking 3, negative 2. And then we're going to be evaluating the test point. So in this case, evaluate 3, negative 2 into the original inequality. So y is greater than 3x plus 1. Your y value is negative 2 greater than 3 times 3 plus 1, or negative 2 is greater than 9 plus 1. Negative 2 is greater than 10, which is technically false. Now, what this does is the following. We tested a coordinate point below, and that came out to be false. So that means that the solutions are all the coordinate points above it. And we typically just shade that portion of the plane. And that's it for this problem. So your solution, it's technically the line, and then also the shading portion that we're doing In this case, this shading that I'm doing here means that you're basically graphing or selecting all the coordinate points above the line. That's actually it for these problems that are two-dimensional inequalities. We're pretty much selecting one side of the plane. A lot of the problems are gonna ask for test points. For the test points, you pick a coordinate point that you're sure it's below or above the line. If this had been true, then you would have shaded that portion of the plane. Let's take a look at another one, and then I'll show you guys a quick shortcut. So for problem 2, we're actually going to graph y is equal to negative x plus 1 with a y-intercept of 0, 1, and your slope is negative 1 over 1. So let me plot it. In this case, we're talking about 0, 1. It's here. Slope is 1 unit down and another one to the right. So we're going to be graphing or putting a line through those 2 points. Notice that in this case, the line has a statement of less than or equal, so it's going to be solid. I only wrote dotted on the previous one because it was a greater. So on this one, let me do the insert of the line. Okay, let me make it a little bit thicker just so that it's clear which side of the plane we're looking at. Okay, and then the next portion, we're going to be doing test points. So for the test points, let me pick one that is going to be easy to evaluate. In this case, 0, 0, which is the origin. So as we evaluate, the coordinate point 0, 0, you're looking at y is greater than or equal to negative x plus 1. So 0, in this case 0, it's less than or equal to negative 0 plus 1. Means that 0 is less than or equal to 1, which is technically true. What that means is that we're going to be shading the actual values below the line. If testing 0, 0 would have been actually a false statement, then we would have shaded the line above it. That's actually it for these two. I'm going to show you how these look using technology, but let me pause the video for a minute. Okay, so let me show you how these look using technology. The first one is y is greater than 3x plus 1. And in this case, let me activate. That's our line. Notice that, let me make it a little bit smaller. And notice that in this case, that's your line, and we're shading every coordinate point. That's every coordinate point above the line. The second one The line was less than or equal to 1, and this is what it looks like. So let me make it a little bit smaller. And notice that, well, we tested 0, 0. In this case, 0, 0, it's very close to the boundary, but all your coordinate points is the lines below it. That's actually it for these two problems. I'll put the other ones in another video.